I'm gonna post a link to the Hangout onto the Google or onto the YouTube video. Hopefully you guys can hear me. Um, nope, can't do it that way. Hold on. It sounds like it might be really delayed right now. So if you can join the Hangout, that'd be good. So is anyone able to make it into the Hangout? Okay. Sorry, trying to see if anyone will join it. Looks like there's 4 people watching right now. Give me a little bit of time. Today, of course, we didn't have class today, so it's going to be a little complicated. And it looks like um, only 3 or 4 people are here right now. But that's okay because it's going to be recorded and the other people in the class can watch it at their own time. But I appreciate everyone that's here right now. So we're going to go through a short class today um, because I don't even know if this is going to work correctly, and I don't want to waste too much teaching on an unproven technology. Let's see, there's one person in the Hangout right now. I mean, Cody, Andrew, Stephanie, do you guys want to come in to the Hangout? You can feel free to hang out with us. Let me pull up Notepad. Hopefully this will. This will work the same as in class. Let's see. Okay. So let me pull up the syllabus. If I can find it. Okay, I'm pulling up the syllabus. But mainly, we're going to be going through the increment slash decrement operators. And then we're going to go through loops, and we'll spend the majority of our time there, probably all of our time. And if we can, we'll get to file I/O. Let me put this on Java. Okay. Let's see. Syllabus. Let's see.
It's kind of hard to see.
How does it look?
It's just blurry. Like you need to zoom in a little bit.
All right, let me try something.
That makes any sense.
Yeah. That's the wrong one. Today we did. So it's complicated. It's like only right now, but that's okay. It's going to be recorded.
It's kind of hard to see.
You're going to class. After, but I appreciate everyone. Okay, there's a little bit echo. Make sure you mute yourself if you can. Is this better? Is this clearer? Here you go. I can't hear you guys. I don't know why I'm asking you. The Hangout link's in the description.
There it is. Microphone's muted.
Okay, so can you see the screen? How does it look? Look okay?
Much better.
Does it look like there's half a screen next to it?
Yeah.
Gosh. All right, hold on one second. Let me try. Let's see if I can set this up. Yeah, it's gonna be a little bit of a trial and error. There. Okay. So one screen, one full screen. Looks clearer, right?
Yeah, that was good.
All right, thank you.
To me at least.
All right, so we're not starting that up yet. Okay. So yeah, we're all the way down in this class, 224, which is supposed to be last week, but we got pushed back first day. So we already did variable scope, we did control flow switch. So now we're just doing these guys, and then hopefully file I/O. So just copy these over because these are good. Put these dots in. Okay. So we're going to go over, first of all, a couple operators that are good for loops, and they're the increment and decrement operators. So they look like plus plus and minus minus. So plus plus is the increment operator, and minus minus is the decrement operator. They're both unary operators, so they only take one operand. But the neat thing about them is you can put them before or after the operand, and they have a different effect. So first of all, plus plus adds 1 to its operand. So it looked like plus plus or operand plus plus or plus plus operand. And then the decrement operator minus minus operates the same way, or minus minus operand. See how there's no space between the plus plus and the operand, so there's no space here either. It's kind of like how negative works and the exclamation point reverse the true or false. So these ones both, this one adds 1 and this one subtracts 1. So there's a big difference between if you put it before or after the operand, and that's called, if you put it before, it's called prefixing the operator. And what that means is that if you prefix the plus plus or minus minus happens first in the statement. This will make more sense once I go over the order of operations with these guys, because it gets a little tricky. So putting it before, it happens before the statement executes. So it's the first thing to happen in the statement. If you put the operator after the operand, it's called postfixing the operator. So if you postfix the plus plus or minus minus happens last in the statement. So it's kind of like you can control the order of operations. Is a cool feature, sort of, but it sometimes leads to a lot of code confusion, and if you use it incorrectly, it's kind of hard to track down. So, I mean, a lot of people don't like this, that you can prefix and postfix them, but as long as you know what you're doing, it's not that bad. Okay, so for example, for prefixing, it would look like plus plus x. So you could put it inside a statement. So if we want to print out the value of x incremented, let's say we have an x equal to an int. We have it set to 0 first. Then this prints out 1 because the plus plus happens first. So this is exactly like having int x equals 0, then doing x plus equals 1, and then printing out the result. So you can see the plus plus happens before the print statement. Now the postfix, with that same statement, so let's say we have these two statements up here, initialize x to 0. Then we print out x plus plus. This actually prints out 0. But x still has a value 1 at the end of that statement. So this is exactly like int x equals 0, system.println x, and then x plus plus, or x plus equals 1. So let's actually try these out in NetBeans, so you don't just take my word for that. So and hopefully everything will work out as I said. Okay, so let's copy the first one. Should print out 1. And I forgot an entire word in here. Okay. So let's put in a message in here. So, okay, that's printing as we expect. And let's do postfixing. Let me add these outs in here so for the benefit of later referring to this. Oops. Okay. So we're resetting x to 0. And let's run it. So it should print out 0. Yeah, okay, good. I'm right in that case. Okay, but x has a value of 1 afterwards. So if we print it out after that statement, x has a value of 1. So it's exactly similar to incrementing 1 after you print out the x. So the plus plus postfix happens after the statement executes. It's the last thing to execute in the statement. While prefixing, it's the first thing to happen in the statement. So it's kind of easy to remember. Before, then it's before the statement. If it's after, then it's after the statement. I would normally do bonus questions at this point, but I guess we'll just skip bonus points for now. And let's give whoever's in the Hangout like 3 bonus points. Okay. So that's on the loops. There are several kinds of loops in Java. We're going to go over 3 out of 4 of them today. We'll go over the 4th one when we get to arrays in chapter 8. But these 3 are the main kinds of loops you'll find in Java, and in pretty much every language has some kind of variation of these 3 loops. And they're listed in the title right here. We have while loop, a for loop, and a do while loop. So we'll start out with the while loop. So loops are kind of like if statements, but the statements inside the loop body will continue executing until the Boolean expression is false. So it's a way to execute code repeatedly without having to type it out however many times, or even if you don't know how many times it's going to execute, then it'll keep on going until the condition you have is false. So let me put out the syntax for you so you can see. It's very much like an if statement. So we have the while, then the Boolean expression inside of parentheses, just like if, followed by an open brace, just like if, and then the statements in here, and end with a closed brace. So you can see it has the exact same structure as if. There's no semicolon at the end of it. You can have as many statements in here as you want. You can have if statements in here if you wanted to. You could have more while loops in here. We'll get into that later. And it just keeps on executing these statements until this Boolean expression is false. So when the execution sequence hits the bottom of the loop, it goes back to the top. Hence the loop. So it starts here. Let's do a solid example so I can walk through it for you. So let's say we wanted to print out like the numbers 1 to 100. So we'll use our friend, the increment operator that we just learned about, and we'll use a loop. So initialize a variable. You start at 1 if we want. And we'll say while, we'll put a Boolean expression is in here. So while count is less than or equal to 100, then we'll print it out. So system.out.println count, and then we can do the trick with the increment operator and just put it in there. So it'll print out 1 first, then it'll increment it to 2, then it'll come back to the top of this loop, and it'll check this condition again. So 2 is less than 100, it'll print it out again, print out 2, then increment it to 3, and go on. And then once it gets to 100, or really, yeah, once it gets to 100, 100 is less than or equal to 100, print out 100, it'll add 1 to it, then it'll be 101. 101 is false, it's not less than 100, so it exits the loop and continues from there. So we can put another statement out here, just prove it exits. Actually, I want it to be, let's do a little bit of printf in here just to space it out. Okay. So you see it counted every number from 1 to 100. So it's better than writing out this print statement 100 times, for sure. Where's it? There it is. So once the Boolean expression, so it goes back to the top, and what does that mean? It goes back to the top and checks the Boolean expression again. If the Boolean expression is false, it exits the loop. If it's true, the loop statements are executed. So does anyone have any questions about that so far with the while loop, how it works? Okay, well, we'll get into more details with it right now. So let's say, hold on. So it's important to note that it has the same programming style as an if statement. So you definitely have an open brace at the end of the while, and then you have a tab in here. You're spacing an indent, basically, for all the statements inside the while loop. And then you end the while loop with a closing brace at the same indent level as the keyword while. So style-wise, just make sure you indent everything inside this block, because it's a new block. You can put new variables in here, just like the if statement, and they'll only be in scope inside of this block. And every time the loop is executed, the variables will be reinitialized. But we'll go over all that as well. Let's see. So let's do another example where, say you have like a password checking device. Or loop. So loop password example. So for this, we're going to accept user input until we get a password, or until they've had 3 tries. So we say system.print enter your password. So let's first do it just so they only have 1 try. Let's say the password is password. So we'll get the input from the user, create a scanner, so we can read the keyboard input. Then we have to import the scanner. Then we have to get the input from the user. Okay. And then we'll compare that to the password. And we'll just say equals. We want it to be case sensitive. Then we'll print out a message, access granted. Otherwise, else, we'll print out access denied. No exclamation point. Okay, so it's pretty simple. We learned if last class. We know password.equals. That's how you compare strings, and it'll return true if they're equal and false if they're not. So let's try it. So let's say our password. We don't know what our password is, so we're just trying things out. And we're denied. We have to rerun the program. We get password, then we did it. So one thing, what if we wanted them to have unlimited attempts? So what we would do is we'd surround. First of all, let's get this keyboard up here. We want to ask for the password, get the input, and then compare the password to the input until we get the correct password. Otherwise, we're going to deny them access and ask for a password again. So how we can do that, we'll do a while loop. So what can we put inside this Boolean expression? Well, we can use a Boolean. So we can initialize a Boolean with some kind of a variable. We can call it password match equals false. And so, or we start off with password not match, because we want it to continue until they get the password matched. So while password not matched, then we're going to print out enter your password. And then we're going to get the password entry from them. And then we're going to see if the password is equal to the input. Then we're not going to just print out access granted. We're going to say that's password not match. It's actually equal to false now because it is match. You guys can do this the opposite way. You could say password. In fact, I'm going to do that so we can use the exclamation point. It's easier that way. So password matched equals false. And then you can use the exclamation point we learned about last class to switch what it is. So we're saying while not password matched, then we're going to do this. And then set password match to true. Otherwise, we're going to print out access denied. and then it'll go back to the top. And password match is already false, so we don't have to set anything here. So now, after the loop executes, after our password's matched, we know they entered the correct password after here. So we can print out a message, access granted. And then they can continue execution of the program. If they can't get the password, they're stuck in this loop forever. So let's try that out. So the only way to exit this program is to stop it right here, or to enter the correct password. So you can see how we can use the while loop. We don't know how many times we're going to loop through. It's just until they get their password matched, then it stops looping through the while loop. So we could also add in, we could make this even more complicated if we wanted to do an attempt counter. So let's say there are max attempts of 3. We can set this actually as a constant. So you can say max password attempts, because we'll assume there's some other part of this program that's more useful than password entry. And we'll keep an attempt count. And we'll start counting at 0. So while not password matched and attempt count is less than max password attempts. So we remember from last class how we used the double ampersands just to use 2 conditions at once. So this is only true if both sides of this AND are true. So if password's not matched, so as long as this is false, then this part's good. And then as long as the attempt count is less than the max password attempts. So as attempt count, we can use our increment operator. We could do it like this, and that's perfectly legal. Or we could put it down here, and that's fine. So you can put it on a statement by itself. This is what most people prefer, so it's clearer what's happening. Or we could put it up in here because we know it's going to happen after this statement is executed, and it'll still accomplish the same result. We'll just do it this way because technically, stylistically, this is what people prefer. In Java, at least. In some languages, they want it as condensed as possible. In Java, they want it to be a little easier to follow. So the one thing about this is that now when we exit the program, or exit the loop, we could exit the loop 2 ways. We could exit if we matched password, then not password matched would be false, so it would exit the loop. Or it's going to exit the loop when the attempt count is equal to or greater than max password attempts. So even if they don't get the password, then they get through this loop. So we're going to put another checkout here. And when we learn about methods next class, then we'll learn a way to exit out the program. But we're going to say they correctly hit the password out here, because password matched is on the same block level as the main statement, so we can access it over here. Otherwise, access denied. So yeah, methods work really well with loops, and so we wouldn't have these double printouts here. We could make this message the final one. And also, we can do something like actually tell them how many attempts they have left. So put it down here, say you have let's use printf. It's really max password attempts minus attempt count. Hopefully you guys are following this. You can totally jump in and ask me any questions. So now we have 2 attempts left. We have 1 attempt left. So you can see, put it, enter right here. What a couple of you did in the lab, which is actually technically more correct for /n for printf statements, is you can use %n, and this will put a new line for whatever environment you're in, because some environments don't use /n, they use like /r, /n. But /n still works. I think that's fine, but I just saw somebody use %n and looked it up. So that would totally work too. Yeah, of course, if we got the password correctly on the first try, then we wouldn't see any of that other work we have. Except it says you have 2 attempts left, which is not what we wanted. So we'll put this in here. So now it'll only print out that message if the password doesn't match. Okay. So another thing to note is that what if we didn't ever exit the loop? What if we had something else like where the condition was never true or never false? So we have our while statement. We want to count to 100 again. But say while the count is above 0, then we'll continue. And then print out our message afterwards. If we try to run this program, if you try to step through it right now before we run it, first of all, okay, we can do this. It looks pretty similar to our loop example number 1, except you use a printf here. But there's one major difference between these two. Let's see if I can put them up at the same time. I don't think I can. Oh, yeah, I can. Okay. So you see, this is the original example. And then this is our new example. If we put a printf in here, let's make it look pretty much like that one. And we'll put the count equals 1. It looks very similar, but there's a major problem with this one. Let me see if I can put this back in. Yeah, okay. So we run this one, and it's just going to print an infinite number of 1s. Hopefully it'll crash. But no, it looks like it's going to run forever. So that's what's called, if you look, you just have 1s printing out the wazoo here. And I had to physically stop it by pressing the red square right there. which is an important thing to know when you're working with loops, is how to stop it. So what we had here was called an infinite loop, and the reason it's called an infinite loop is because it runs an infinite number of times. There's no way that this condition is going to be false because we're not actually incrementing the count. So it's just 1, and then it prints it out. It's 1 is less than 100, so it prints it out again. 1 is less than 100, prints it out again. It keeps on doing this loop forever. So you really have to watch out for that. You have to make sure that the condition could eventually be false. So in our other one, in our password example, without the max attempts, technically you could have an infinite loop if the user never enters the correct password, but that's not necessarily a bad thing, because that's really just the user causing the infinite loop. But this is an infinite loop that no one can control at all. So infinite loops the loop could execute forever if the Boolean expression is never false. It can never be false. So I showed you one way to do that, which is to never increment the count. Another way that's a little more tricky, let me close these guys so it's easier to see. I can zoom in, cool. Another way that's even more tricky, so let's say we fix that loop, and we have this now, and it runs exactly like the other one, counting to 100. And then let's say we don't really know how to write while loops, and we think they're just like normal statements, and we just put a semicolon right at the end of it, and we think that looks fine because that's what every other statement has. So NetBeans will tell you there's an empty statement after a while. An empty statement just means exactly no statement with a semicolon. So it's the same as this. It can be on its own line, but some might put it right there after the while loop, and it could even put it on a brace afterwards, and this looks correct. But what this does is it prints out nothing. It just seems like it's running forever. And what it's doing is it's executing this loop, then it's executing this empty statement, and then coming back into the loop and checking if the count is less than 100, and it keeps on doing this an infinite number of times, or until if you were running a method in here, it would give you a memory error at one point or another, hopefully. But it's not going to give us anything in here. It's just going to say running forever, and this is a cause of a lot of frustration, especially among last semester's class. So pay attention, don't put the semicolon right after the while loop. And if you see yellow squiggly lines, investigate what they say. Because I guess this doesn't even make any sense. Surround with ... What does Alt-Enter say? Yeah, they don't say anything. So you gotta keep that in mind. And let's say you have these on 2 lines. So technically, just like an if statement, you could have no braces after the while loop. And let's say we had it looking like this. Oops. All right, now we have to end that execution. That works fine. Though I hope NetBeans, yeah, while loops must use braces. Heed that warning, because if you had the count on a separate line, this looks like the count will increment each time, but if you don't use braces, only the statement immediately following the loop statement will be executed. So it'll just print out a bunch of ones again. Another infinite loop. So we put these 3 examples in here. So this is one example. And then infinite loop with empty statement. And that one looked like this. And infinite loop with missing increment. So I don't recommend running these examples because they're going to do nothing except print a bunch of ones to your screen. So those are the main 3 kinds of infinite loops you're going to have to watch out for when using while loops. No bonus questions. Skip those. So there's a couple things you can use while loops for other than counting. And one thing that you're going to be using it a lot for the labs is something called input validation. So let's create a new project called input validation. Just checking. Okay. And when I put the pound before the line, it means it's a header. You'll see that a lot. Okay. So input validation, basically, we're going to keep on asking, just like the password example. Here it is. We can keep on asking the user for input until we get input we want. So let's say we wanted a yes/no response to a question. So basically what input validation means is that you can use a while loop to repeat statements until acceptable data is entered. So in our example, we're going to ask them a question and they have to answer yes or no. And if they don't answer yes or no, then we're going to keep on asking them. And it's going to be just like this other example. So first we're going to read a value with a priming read. So in this loop password example, we did it slightly differently than we're about to. We use this password matched boolean and set it to false and then read it through. And I kind of like this way better because you don't have to read a priming read, which we're about to do, and then it compares it in the while loop. But you may like this way better, so let's do this way first. First read a priming. First input a priming read. So we need our scanner. And we need to import our scanner. Okay. And we'll print out a message. There's another problem with this way is that you have to print out the message twice. Which doesn't seem that bad, but I don't like repeating myself in programming. Okay, print out. It's a good yes or no question. Do you like NetBeans? I just saw the comments in the chat. Yeah, Andrew, you're right. I could do that. Okay. Andrew's saying I could show you the special kind of input validation for data type. I just have to remember how he showed me how to do that. So maybe you can jump on in a second. But first we'll do a yes-no validation. So we expect yes or no from the user. So we'll read the value from the user. So this is actually the primary read down here. We're going to set it up there. So string answer equals keyboard.next line. So now we're going to start our loop. So we're going to check if the input was yes or no. And if it's not, then we're going to ask them again until they answer yes or no. So we'll put in a while loop, and we'll say while the answer that equals yes, and we'll ignore case this time. So this is not the final, what we're going to be doing. I'm just doing this right now. So we want yes or no. But this doesn't give us what we want here. Because a while loop continues to execute until what's in here is false. So if we say it's yes or no, then whenever they give us a yes or no, it'll continue executing the loop. So what we gotta do, we gotta say not around all of it. So while it's not yes or no, so you see I put parentheses around all of it, then it's going to continue looping. So what I talked about last class is storing the Boolean expression into a variable, which you could do to make it clearer what's going on in here. So you say did answer yes or no, and then store that value in here, which I would prefer. It's a little bit clearer to separate it out like this. So what this will do is it'll give you the result of this equals yes or equals no. And then you can say, well, they did not answer yes or no by putting the exclamation point before it. So stylistically, I think this is a better way to do it because it's clear what this while statement is actually testing. But it's all up to your own I don't know what I'm trying to say. Your own volition, I guess. Your own will, whatever you prefer. But in the long run, this is going to look clearer to you. So while they didn't answer yes or no, then we're going to get another answer from them. And again, this leads. We'll have to store another variable for this. We'll do this in a second. So while they didn't answer yes or no, we're going to print out another message saying, answer yes or no, do you like NetBeans? And then we're going to get the answer from them. And this answer is still in scope, so we can't declare it. Just have to reuse that old variable. And NetBeans complaining because we're not using it. And then we're going to reassign this. If we just had it in here, all in here, then we wouldn't have to do this. But again, it's all up to you, but this is clearer ultimately. Yeah, more lines of code is not a bad thing. If you have, but repeating code is a bad thing in my opinion. So this does repeat code. As you can see, we ask for the input multiple times and store it into answer, and then we assign this variable multiple times. But that's not too bad. For the sake of clarity, it's good. So while they didn't answer yes or no, then we're going to keep on asking them until they answer yes or no. And then we can print out a message at the end. So if they answered no, then we'll just print out a message telling them to go use Eclipse if they want. Otherwise, else, we can print out wow. Just wow. I use NetBeans, so I really have nowhere to talk. So I know you guys. I know Andrew hates it. Do you like NetBeans? Yes. Wow. Just wow. So since we said yes or no, we don't even go through this input validation loop. Our input was already validated. Let me put it in here. If we answered something else, then we can have a conversation with the computer. So if you're feeling really lonely, you can have a input validation loop conversation. So you can see it just keeps on asking until we say yes or no. And since we use case insensitive compare, then we can do a capital NO if we want. So we continue executing loop until we get the input we want. So let's see, Andrew's way of doing input validation. So some of you may have been wondering how to actually get a number from the user instead of letters. So say we want to force them to give us a number, an int. So we're going to use an input validation loop of a slightly different kind. So say, how old are you? And we'll get our scanner. And we'll import our scanner as usual. And then we'll use the input validation loop. And let me see if I can remember how to do it. Otherwise, Andrew's going to have to jump in somehow. So we continue to get values from the user. So they look like this, Andrew. You can jump on the chat if you want. And so we continue to look through here and we say, well, the keyboard doesn't has next int. Is a special method in scanner. Let's see if it'll pop up. No. Let me pull over a window so we can look at the old Java docs. Oh, that's 1.5. We're using 1.7. And this isn't what I wanted at all. There we go. So if we go to has next int, you can see we have all these methods here. This isn't really going to be on any test or even in the labs, but I know a lot of people are curious about this because people asked all the time last semester. So returns true if the next token in this scanner's input can be interpreted as an int value in the default radix using the next int method. So it's basically saying the next input, if it's a number, a base 10 number, then it'll return true. If it's not, if it's like a word or something, then it's going to return false. So we can verify that the next number or the next input is actually a number before inputting it. So if it's not the next int, if it's not a number, then we're just going to consume whatever they input and not even care about what it is. And then say, come on, enter a number. How old are you? And then continue on and on. Well, it's going to jump back up here and keep on consuming lines until we get a has next int equals true, and then we can store that value to the age. You're that old at age years. It generally is not a good idea to insult your users, but it makes it for an interesting user interface, ultimately. So you can see it just keeps on eating up the input and checking if it's a number or not. As soon as the next number, it kind of peeks ahead and tests if it's a number. And if it's a number, then you can actually call next int afterwards, and you'll get the actual number. So yeah, if you don't do it this way, if we didn't have this input validation loop here, just comment it out. And we tried to have that conversation with the computer, then we get this problem here. I think it looks different than when we ran it in class, but it's an error at any rate, and it's not as pretty as just printing out this input validation statement. So there are ways to handle those errors, those big red errors that pop up, but that's out of the scope of this class. So you can use this way if you want to ensure that you get numbers from the user. But again, that's optional. You can, in this class, you can let it throw out those errors. So we've done strings. We could do, I'm going to leave the ways to ensure like the numbers entered between 0 and 20 or 0 and 15 up to you guys, because that's actually one of the labs. So you can, it's just like the if statement, you have to verify that the number's within a range. If it's not, then you keep on asking for a number. So, but these should help you through it, especially since this one has one of the relational operators, or the logical operator, sorry, the or. Ranges would use an or an and. So the steps in here are first, I guess I'd put a 1 there, so I don't need to say first. So read a value with a priming read. Then to test that value as a Boolean expression in the loop. And 3, or really 2a, if it fails, print a message and get another value. And since it's a loop, that'll automatically try again. And 3, you'll have a valid value for the rest of the program execution. Assuming you don't change it later, but that's another story. Okay, so that's the while loop, and I have in here, I have the do while loop next, which I don't know. The do while loop is pretty dumb. I mean, it's not dumb. I'll do the do while loop. Let's do the do while loop. The do while loop is like probably the most complicated and least used loop of Java. So just like in the beginning when we talked about prefixing operators and postfixing operators, do while is a way to post-test the while loop. So instead of testing before you execute the statements, you're testing after you execute the statements. So ultimately, it's actually pretty useful for input validation, and I'll show you why. But first of all, let's start with the syntax. So the reason it I think is like the most complicated is, first of all, you start out with just do and then brace. So it has the most complicated syntax of all the loops. If you're following me. Then you have your statements in here. Then you close the brace. Then you say while, and then you have your Boolean expression. And then one major annoyance is that sorry, I just read Andrew's comment. You have to have this semicolon at the end for the complete statement. So since the while doesn't have a brace after it, you have to have the semicolon at the end, which is totally confusing, I know, but really just have to think of it. It doesn't have the braces at the end of it, so you have to have this. And the whole reason they have the while at the end and everything is so you can trace it more easily, so you know you do these statements first and then you test the while. So you could put it all up in here, but then it would be even worse. So the important note, as I said, the do while loop is a post-test loop. I think that's all one word. And I want that, quotes. Which means its Boolean expression is tested after each iteration. So if you're following the while loop, the Boolean expression is executed after each execution, but really the major difference is that on the first execution, this while loop is tested, so it's kind of like an if statement, it won't execute these statements unless this Boolean expression is true. But with the do while, it'll always execute these statements at least once, and then it'll test this Boolean expression. And if it's false, then it will just continue the program. If it's true, it'll go back up to the top of the do and continue. So one note up here, notice, or I guess note the semicolon. And since it's a post-test loop, I'm going to say is guaranteed to run at least one iteration before testing. For testing the Boolean expression. So let's do an example of that. Oops. I guess I could, no, I couldn't have. Do while example. Let's do an input validation with a do while loop, and we'll do it with, say we only want negative numbers. So we're going to get our scanner, just set him up because we know we need him since we're getting user input. So we're going to be using, I mean, you guys already know this, but user input is always scanner, but there's the other option of the dialog boxes. But just stick with scanner for now. If you really want to use dialog boxes, then just let me know. We'll figure something out. Oh, here it is. So we want a negative number. So if the number is positive, we're going to reject it. So user number, and we're going to start with a nothing. We're just putting this up here so we can mess with it outside the block. So this is what the do while is ultimately going to look like. And we're not going to do the input validation to make sure it's a number. We're just going to take whatever they say, and if it's not a number, then our program's going to crash. So do while, we're going to say get the input from the user, so we're going to print out a message. No, that's just a statement. It's not a question or a colon. Okay? Give me a negative number, and then we're going to get the input from the keyboard. Yeah, Andrew can help you with dialog boxes, for sure. But we'll talk about dialog boxes. No, we won't. We'll talk about them later during GUI input. You can definitely use them then. And that's chapter 7. Okay, so user number equals keyboard next int. So we have our number in here. So we're going to say while user number is greater than or equal to 0, then we're going to keep on looping. And then once we get out here, say, thanks for that negative number. or say negative, and then we're going to print out the positive user number by using the negative operator. Just to be super cool. So you can see here, it's kind of like input validation, but we didn't have to do any priming reads or anything because we're guaranteed to run at least once. So we can get the negative number. And then replace that negative sign with this word negative, and then negated the number to get the positive number. Just so you guys remember, there's this operator. So you can see it kept on, we didn't get to print out a message. We could print out a message in here if we put another if statement in here. So if the user number is greater than or equal to 0, they could print out. That's not negative. Who are you trying to fool? And you can keep on harassing them. I can ask you this all day. And so this kind of, you kind of have to test it twice if you wanted to print out a message in here. And it's input validation. So you can use this style if you want. It's totally fine. There, you don't see very many do whiles in the wild, if you will, but to each their own. You can totally use these. I will not judge you. You can space them out. You can put spaces in here and here and here. It's been a lot of spacing I've seen. Put one right there. Spaces everywhere. Okay. So there's one more type of loop. So we've gone over the while and the do while. We'll put these in order. And now we're going to go over a loop called for. My for loop is the one you'll see the most often, actually. So the syntax of the for loop, we're just going to put it right after here, follow this pattern, is you have a for, then you have your parentheses, just like all the other ones. But then you have an initialization statement. It is going to be, what's special about here is this for loop doesn't just have one statement inside of these parentheses, it has 3. First is the initialization statement, and that one happens first. Then the Boolean expression, and that's just like the Boolean expressions inside the while loop. And then the third part is the update statement. Then use a brace afterwards. Put some spacing in here. And you put your statements in here. And then you finish it off with a closing brace. So you don't need any semicolons in here besides inside with the statements. And, oh yeah, in here too, to separate the 3 statements. So let's explain what all these mean now. Start with an example. Yeah, we've been starting with examples. Let's start with an example for the for loop 2. Okay. So we're gonna, instead of counting to 100, we're gonna count down to blast off. So we're gonna have a for loop, and all we're gonna write is a for loop. That's all we need. So we have the for, and then we have an initialization statement. And so this initialization statement is the first thing that happens, and it only happens once in the loop. So typically, it can be used to initialize a variable called a control variable, which basically is used during the test to determine if the control variable is within bounds or not. So what does that mean? Let's start it up. So let's say we wanted to count down from 10. I'm going to leave that no space there. So start with initializing a count variable to 10. So this variable is going to be in scope within inside the for loop. It's not outside. So once we're outside of the for loop, it's gone. But we can use it throughout the for loop, and it maintains its value. So that's our initialization statement. Just write down that note for initialization statement. It's a good one. The first statement that happens, and it only happens once. And it's usually used to initialize a variable called a control variable. So we're going to put in here, since this count only has to do with inside this loop, we're just going to initialize in here and only use it within this loop. So that way we can use count later if we wanted to in another part of our program. So now we have, if we look back right here, we have our Boolean expression test in this next part of it, part 2. So we're going to say while the count is greater than 0. Greater than 0. Because we're going to count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. So that's all we have to do. As long as it's true, this Boolean expression is true, then the loop will execute. So the third part of the loop, parameters up here, is the update statement. So in this one, we're going to update our control variable. So this is a full statement, so even though we're using the postfix operator, it doesn't matter if we're using postfix or prefix because the statement gets executed completely before moving on. So what we're going to do in this one is we're going to update our control variable to be one value higher. Or no, we're counting down. One value lower. So that gets executed at the end of the loop. Did I write down what? No, I didn't write that down. Boolean expression test. Is like the while loop. As long as the Boolean expression test is true, the loop will iterate. Yeah, iterate's a fancy word for execute. When the loop runs, it's called an iteration. Okay. And it is tested before the execution or before each iteration / execution of the loop. So just like the while loop, And unlike the do while, it's a pretest. And then our update, we put that in here. Let's write it down. Update statement. So this is generally where the control variable that is initialized in the initialization statement is updated. And most of the time, it'll usually is updated with the increment or decrement operator. So see, that's why we learned increment decrement just now, because we're using these all up in these loops. So a couple important notes. But let's finish this program first, and then we'll talk about this update more. So we're going to print out the count, and then at the end of our countdown, we're going to fulfill this java.comment up here and print out blast off. So it works. Hooray. So you notice that the value 10 was printed first. So we set the value in initialization statement to 10. We check if the 10 is greater than 0. And then we execute this statement. When we get to the bottom, then we do the update. So the update happens last. And then this executes again. It's tested. So once that update happens, it's 9. 9 is greater than 0. Prints out 9. Comes back. Does the update statement again. Tests it. Prints it. Goes back until we get down to 0. So once we're at, let's say we're on 1, we go up here, we do 1 minus minus, and that's 0. So count 0. 0 is not greater than 0. So ends the execution of the loop, exits, and then it prints out blast off. You can see it doesn't print 0 down here. And it also prints 10. So what to take from that is that the initialization happens first, the test happens, and then we do the statements. So we skip over the update on the first iteration, and then we never come back to the initialization statement again. We just do the update and then the test, then the print. The update, test, print. So initialize, test, print, update, test, print, update, test, print, and so on and so forth. So, put our notes. Update is executed after each iteration of the loop. Before the Boolean expression is tested. And the other note, update, say the update statement. The update statement is not executed on the first iteration or before the first iteration. So let's see if I have another for loop example. So it doesn't just have to be an increment or decrement. It could be many things, but let's say we wanted to count down by 2 each time, so we only had even numbers in here. So So we could do minus equals 2. So this assigns the new value to count. And then we have 10, 8, 6, 4, 2, blast off. And additionally, I wouldn't recommend using a for loop this way, but you could write just like a while loop, you can leave out this part as long as you have that semicolon, and you can have count minus minus at the end here, and it's the same thing. And then you could go even a step further and bring this count outside. Then the for loop looks like a while loop with these extra semicolon boundaries. And this will work just like a for loop or a while loop would. But it's cleaner to put it inside of here. Oh, I need that int too. And that set of code was not the same as this code because that count variable has a scope within inside this block. But this count variable only has a scope within this block. So that's a big difference. We can use another count out here and set it to whatever we want. But if we put this out here, then we get some problems. Variable count is already defined. Can't have two variables with the same name. So we'll leave it in there. See if I have another for example here. So say well, there's one more thing you can do with a for loop. Would putting null be the same as just a semicolon? So like, just put null in here. But you can't put just null in there because null is not a complete statement. And this has to be a statement. So it couldn't be like just like 10 or something like that, or just a variable. Like null with a semicolon like this. You can't do that either because it only wants these two semicolons in the for loop. They operate as like separators. So the last semicolon is just implied. But yeah, this has to be a statement over here. So it can't just be count because that's not a statement either. A full statement something needs to happen. Just like you couldn't have count on a line by itself out here, or null, or anything. Something has to happen in each statement. So let's use a for loop to display the cubes of each number in a table format. So let's say we wanted to have a table that has the number, and then to the right of it in the next column we want the cube of that number. Let's do a number, the square of the number, and the cube of the number all in the same line. So we'll call it square cuber for loop. So just print square and cube of a number So we could do something, we could even ask the user for a number. So we can ask them for a max number, just so that we can include the user in this. We'll import our scanner. Yeah, we're definitely not going to get to file I/O today, I don't think. We'll just do loops, and then we'll cover file I/O next class. Okay. So we're going to get a So we're going to ask for a number greater than 1. So we have to do input validation to ensure we get a number greater than 1. And we're going to do input validation. We're going to make this really complicated just for fun. We're going to make sure it's a number, and we're going to make sure it's greater than 1. So let's do it. Let's break this down into steps. Gain number greater than 1. And validate it. So the first thing we'll do is use this fancy stuff here and actually get a number. So I just totally copied it out of the input validation loop of ensuring it's a number, but we can't ask how old they are after asking for a number greater than 1. And we can't even ask for that. We can do that. That's fine. So that's the first thing we'll do. And then so we're nesting these loops, which we're going to go over in a second. This is a good segue to it. Sorry, hold on. Okay. So we're going to use this kind of style. First, we're going to say number. So we're going to say while we're going to initialize the number first. Number equals 0, because we know 0 is not greater than 1. Oh, I'm in the wrong program now. Great. Okay. Okay. We're going to put this number first up here so it's in scope before the loop. So first we're going to check if the number is greater than 1. Or while number not greater than 1, really. So you can say less than or equal to, or you could do it this way. Whichever way seems more clear to you. And this loop is going to make sure we get a number. And then we're actually going to get the number. And then we're actually going to test it at the end of this loop and say, well, a number is not greater than 1, then we're going to go through this rigmarole again. So we can say validate the number is greater than 1. So you can see it's kind of out of order writing it, but as you saw, you can write it in any order you want. You can write the while statements first and then surround it with a while loop and indent this stuff. You don't have to write it one line at a time, but when you read it, you'll know what's going on here. You can say the number is equal to 0, number is not greater than 1, so it's going to execute this loop, and then it's checking if the keyboard has a number in its input. If not, we're going to ask for a number greater than 1 and for a value. And then when we get down to here, we know this is a value because this verified it, or this validated it. So then we come up here, and we actually test if it's greater than 1. So one last thing we have to do is actually print out a message if it's not greater than 1 down here. And we can just print out the same message. That's fine. And we can print out a different message here, just to be clear. So now we've done all our input validation. And what this will do, let's rename this variable. So one trick in NetBeans is that something called refactoring. So if you ever had a variable that you wanted to change the name of, you could click on it and you can see all of the same variable names. But if you right click and you go to refactor, there's a little thing called rename. And you can use this to actually rename every instance of that variable. So you can see we have number. You can preview it. When we preview it, it gives you how it looks different. So this is where the original, this is the after. We press do refactoring, then it will change the names of all the variables for you for that. It's a pretty neat trick. And if you saw when you right click, refactor, rename, you can use Control R. If you press Control R, then it highlights in this box, and you can change it all like on the fly inside the editor, which is pretty cool. And then when you're done, you press Enter. So that's a pretty neat trick with NetBeans. Most IDEs have that. Otherwise, if you're not using an IDE, if you're using Notepad or something, then you have to use replace, and that can lead to unintended results if you don't have the correct find statement. So this just ensures that it works correctly if you use Control R. Okay, enough of a segue. Let's get to the actual for loop. So use a for loop to print the table out. So we're going to go from 1, and we're just going to call our counter I. There's a common thing you'll see in programming is that counter variables will start with I, and then so they'll just use like throwaway variables with the name of I, and that just means index or count. So for I is less than the max number the user gave us, I++. Let's print out their number too. So I is less than or equal to the max number. Then we're going to use a printf. Let me do it this way so you guys can see this way. So you can, instead of doing printf, you can build your string first and then print out that formatted string. So if you use string.format, it's just like printf. So what we're going to do is we're going to print out the first number, give it like 5 spaces. Then we're going to print out the second number. Since it's a square, it might be slightly bigger, so we'll give it 6 spaces, and then we'll give the cube 10 spaces. And then the args, those are what the values we're going to give to these placeholders. We're going to put a new line at the end of this. We use %n if we want, or /n. We should use /n because that's what the book does. Okay, so you just need I times I, and I times I times I. So we could use math.power, but since we're only going up to 3, this is shorter. It looks better. It's clear. And then we can actually print out that string. We already have the new line in here, so we could do print line, and that'll add that new line for us. So doing it this way is useful if you wanted to print to the console and to a file at the same time, for example. Hint, hint. Okay. So use a for loop to print the table out, and also let's print out a header first. So we'll do that with printf, and we'll just print out a few strings with the same spacing. So that index, and then the second one we'll call square, and the third cube. Okay, so that's our program. That's our entire program, actually. So most of it is this input validation. Inside here, we're validating as a number, and then down here, we're actually validating if it's greater than 1, and we're validating that twice because we're doing the while loop too. Then we come down here, and actually, this is the bulk of what we wanted to do, but we had to do all this beforehand to get to this point. So number greater than 1, pass it apple, and we get the right number. We're stuck inside this loop now until we actually give it a number. So tease the computer for a little bit, and then we'll give it a -10, and then it'll print out this message. It comes down here. It's like, okay, I have a number now. Let's get the number. The max number is not greater than 1, so it prints out this message, and then checks the Boolean expression up here, and it's not greater than 1. So the loop gets executed again. So let's just end it and give it a number at once. So I forgot this one right here. Let's run it again. It's part of the programming process. And that wasn't right either because I put it in the wrong spot. Programming process, back to step 5 or whatever the step is, if you guys remember from the first class. All right, there we go, finally. So this is the index. You can call it whatever you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the square of each of those numbers in this column. So we want to give it a little more space so it's not so crowded. Could do that. That looks better. So you see 1 cubed is 1, 2, 4, 8, 3, 9, 27, 4, 16, 64, so on. And it works pretty well. So ultimately that was all just in this little for loop down here. But the while loops are just for the input validation. Does anyone have any questions about for loops or about this example yet? Okay. There's one cool thing, or one kind of useless thing you can do with for loops, is that just like I'm just going to briefly go over this because I don't really recommend this at all. But just like when you're declaring variables, you can declare multiple variables at once. So if you just separate them by commas, you could do something like that. And then you could even do multiple update statements if you separate it by commas. But you're doing too much in the for loop at this point. It gets too confusing. So I'm just going to erase it. I mentioned it. That's all I have to do. So, all right. We're going to go over these 3 things, and we'll briefly mention break and continue. I'll get rid of file IO. So 2 different things you can do with loops that we'll be using extensively in these labs or throughout the course. It's one, you can do running totals, and the other is you can use sentinel values. So I'll explain what these mean and how they work and what pattern you can follow to actually execute it. So running totals sorry, just made a ding over there. Okay, Google Effects, nice. Yeah, if you guys put your videos up, you can mess with Google Hangouts if you want. You can put mustaches on this stuff. But anyway, running totals, you can, let me see how to explain this. Accumulate values throughout the loop and then get a total value at the end. And the way this works is pretty easily. So let's do an example. Oops, daisy. I'm redoing this undo. Okay, new project. Example of using a loop to accumulate a total. So say you wanted to get 5 values from a user and add them all together. So the first thing you would do is create a variable called the accumulator, and this basically holds the value for you as you go along. So you initialize it with a variable 0. So you can call it like running total if you want exactly what it is, or you can call it total. It doesn't matter. You can be more succinct. Total. And what this will do is this holds the value that we're going to collect throughout the loop. So it's inside the scope of the main method, so we'll have it throughout. Explain why in a second. And we'll do it 5 times. So we're going to set start I equals 0, and we're going to say I less than 5. So let me explain one thing real quick in here. So we could start with 1, and we could say less than or equal to 5. But as you'll see later on in programming, it's easier to start with 0 and do less than 5 with the same effect because of arrays that we'll talk about later, and how can I explain this easily? Okay, remember when we were talking about strings? Here we go. String JavaDoc. Go off on our segue here. Or not a segue, whatever, diversion. We have this string method called char@. So returns a character value at the specified index. An index ranges from 0 to length -1. You'll see this a lot in computer science, is that Corinne's going for the A. Yeah, the array counter braces. Yeah, we haven't gone through arrays yet, but with strings, the first letter in a string has an index of 0, and the last letter has an index of the length of the string -1. So the string has 5 characters in it. The last character is at index 4. So starting with 0 in your for loops is a good idea, because later on we're going to go through something called arrays that are kind of like strings, that they have an index that starts at 0. So if you start counting with 0 from here, it'll make your life easier later. So just do 0 and then less than a number you want to actually count to. So what we're going to do is we're going to get 5 values from the user and add them together. So of course we got to do our other work first. Create their scanner, add an import for it, and then we're going to get 5 values. So value equals keyboard.nextInt. And we're just gonna print out a message saying print 5, or give me 5 numbers, 1 on each line. So we could print out a message each time asking for another value, but we'll just stay out of the way of the user and let them enter 5 numbers. So the accumulation part of this is going to be the next line. We're going to add that value to total. So let me do another diversion real quick. In lab 1, a couple of you did a trick where for the lab where you had to assign, say you had this total as a short, and we had something like this, and this is an error. If you did total plus equals, then you wouldn't get the error, and some people figured that out and were able to do the lab that way. That's because total plus equals is actually short for short total plus value. So it actually casts the value for you. It casts the result, which is pretty cool. But yeah, sorry, that's neither here nor there. That was the first time I've ever seen it, so it's not very common. Anyway, total plus equal value will accumulate that value into this variable total that's outside the scope of the loop. So it'll stay alive after we're done with the loop. So okay, this is going to iterate 5 times and get a value each time. And then we're going to print out the total. So yeah, in the book they use accumulator a lot, so I used it 3 times in here just to reinforce that. Okay. So give me 5 numbers, 1 on each line. So we want 1, 5, 6, 2, 3. The total is 17. It's magic. Let's make sure. 1 plus 5 is 6, 12. 2 and 3 are 5, 17. So that's right. So you can do other things in here. So once you have the total, you do things like the average is, and then say total divided by 5. So ideally we would store this in some kind of constant, since we are using it 3 times. We have no idea what that means. So if we did that, we could get the average value of all these guys too. So the average is 10, the total is 50. It all makes sense. So that's running totals. Oh, that's the one I wanted. So running totals, you declare an accumulator outside the loop and initialize it with the starting value, which is 0, if you're doing running totals. Then you add values to the accumulator. And this isn't anything special, it's just an int variable. Or you could make it, if you're accumulating money, then it would be a double variable. And then you just add values to the accumulated variable inside of the loop, and then it holds the value of the total after the loop has executed. All right, now Sentinel values are a pretty cool trick too. Let's do the Sentinel values. So a Sentinel value basically means that, say you have a program where you want to input some set of numbers and you don't know how many numbers there are, and instead of asking the user each time, do you want to continue, yes or no, and they press yes or no, so I think of a good example. So say they want to add up the test score. So like in the last example, say you have an accumulator and we want to add up the points for a student, but we don't know how many assignments there are or anything. So we could, let's do that. Let's put out that. Let's do exactly what's right here, and instead of a for loop, do a while loop. So let's say we wanted to input any number of characters or number of digits, and we don't want to stop until the user tells us to. So we'll just say, we'll put a boolean in here called keep going equals true. We could use a do while loop or something like that, but we'll just do it this way because it's a handy way to do things, to store things in booleans. I just want to get that hammered in. Okay. So we get this keyboard value from the user, then we add the value, and then we gotta say if we're going to keep going or not. So what we're going to do is we're going to get another value from the user, call it yes or no, and keyboard.nextLine. But we're going to ask them before this, do they want to continue? And then we're going to store that result. We're going to say if it equals no or in, then we'll exit. So we'll say keep going equals if the value equals yes, right? So we'll accept anything that's not in will mean yes. So keep going equals anything that's not in. So if yes or no does not equal in. So they can use capital N, but yeah, this exclamation point says anything that's not equal. So we could do this, and it's pretty annoying when we go through, oh, give me numbers. Stop this, I don't want that there, okay. So you can do you want to continue yes or no? Yes, I guess. Oh, and I have a problem here. Let's see, throw error input. I see, yeah, we're switching between these guys as well. So that's annoying. I don't remember how to, oh yeah, we had to do this. So we're getting into problems that I'm not even solving correctly right here. Because I chopped it off here and then I got the number. Hold on, let's figure this out real quick. So we did this, we did that, and then we're left with put this in, then we get this error because I can't even remember what happens here. We keep going, and then the next int is entered, and it's not finding a number, but I'm not sure why it's failing at this point. Andrew, do you know? Are you here? You got it? Well, you're right. This is broken somehow, and I don't have time to debug it right now. Let's see, we put in 20. Yeah, that's crazy. Let's see what happens if we put in. Yeah, I'm not sure what's going on here. But at any rate, this is totally broken. I'll figure that out later. So what we can do instead of asking yes or no each time is we can get a what's called a sentinel value from the user. So instead of taking a number each time, we could take a number or a string, and we could say type done when finished, or type a letter when finished. Or we could just say enter a blank line. Would be a good one. You have to pick a good sentinel value, and the sentinel value is, this is getting complicated. Let's just do, give me weights, one on each line. Enter -1 when done. So since weights cannot be negative, technically, as soon as the user enters -1, then we'll assume they're done entering input. So you can say int value equals keyboard.nextInt if value equals or less than 0, then we're going to exit the loop. If this value is greater than 0, then we're going to add to that. The value less than 0, we're going to say keep going equals false. Else, we're going to accumulate the value. So I just changed this to add weights, add an unspecified number of weights. So now we can keep going and enter some arbitrary values and keep going until we enter a negative value or -1, and then it prints out that total. So any value less than 0 is a sentinel value, and we'll exit the loop. So sentinel value signals is a value that signals the end of a list of values. So it can be used to gather an non-predetermined number of values from the user. So you can see this, you'll see this in file input too, is you'll have a set of numbers that'll end in -1 or something like that, and then you can start the next set after you reach that first -1. But as we saw, or as I tried to show as an example, that I'll get to an example next class for sure, is that you need to be careful to choose a sentinel value that is not a possible valid value. So for example, if you ask for temperatures, a sentinel value of -1 would not work because -1 is a valid temperature. So you have to be careful with that. And next class, I'll go through an example of a sentinel value that you can use with a string. So instead of saying, give me a set of values and with -1 at the end, you can say, give me a set of values and then type done when you're done, and then it'll exit when the user presses done instead of -1 or something like that. All right, I said we only go till I can bench press that. So we only go till 9, so we'll just go over nested loops and the loop flow, interrupting loop flow next class. And the lab is not going to be due until the Monday after this one, even though I'll release it tonight, and you guys have 2 weeks to work on it, and I'll figure out the rest of the schedule from there. But we'll go over loops and file I/O, and we'll start with methods next class. So it's going to be a big class. Does anyone have any questions about anything we went through, or have any questions about the lab 3? Because we'll go over lab 3 next class too. Yeah, increments and decrements. If you just use them on a line by themselves, like you can, so if you just use them, like if you did x plus plus here instead of doing it down in here, that's totally fine, and you can use it prefix or postfix, and it would have the same effect because this is a statement all in itself. So yeah, you'll just have to get used to them. But I'll post all these notes and the examples. All right, thanks for joining us or joining me tonight, and thanks for helping Andrew. And we'll talk next Monday. Hopefully we'll have class, and if not, then we're gonna try a 4-hour one of these. So let's hope we have class. But all right, I'll talk to you guys later. Thanks for coming.